Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over question number 4 of the 2018 AP Calculus Free Response questions. We're going to be looking at how to calculate area and volume and also a problem on the application of our differentiation rules. All right, let's take a look at question number 4. It reads, let f be the function defined by f of x equals 6 over 1 plus x squared. Let R be the shaded region bounded by the graph of f and the horizontal line y equals 3 as shown in the figure below. Part A, find the area of R. So we have region R right here, and we want to find the area between these two curves. To get us started, let's take a look at the formula for finding the area between two curves. All right, so what you have to notice is the orientation of these two curves. They're both functions of x. They're oriented in a top-down fashion in the direction of the x-axis. Okay, so when you slice the region, what axis are you pointing to? When you slice the region, you're pointing to the x-axis. So what does that mean? It means that our formula is going to be in terms of x. Okay, had it been oriented horizontally, left, right, so you have something like this and then like that. In a scenario like this, it would be a side-to-side orientation, and it would be in a function of y in a case like this. Okay, all right, but this one is a function of x, so this is what the formula will look like. It's going to be the area between the two curves, between these two curves. Let's call the one on the top, let's call this f top, okay? And then we'll call the other one f bottom. We only care about this region right here. So this function is at the top in this shaded region, and basically this function right here, this rational function, and then the linear function is the bottom for the region. Okay, so we have f top and f bot. So the formula for the area is going to be the integral from the x value on the left side, so x left to x right, of f top function of x, okay, minus f bottom, and we're integrating with respect to x. Had it been it were oriented in the left-right fashion, in a horizontal fashion, we're going to have the integral from y bottom to y top of f left minus f right. That's basically what it's going to be, and it will be dy in that case. Okay, so let's go ahead and apply this formula to this scenario that we're dealing with right here. So x on the left is the lower of the two. This right here, if we trace it down, we see that it's 1, x left is negative 1, and then the right endpoint of our interval is positive 1, so x right is positive 1. All right, and then our top function f top is going to be the rational function, which is 6 over 1 plus x squared, and then the bottom function is going to be the linear function y equals 3. Okay, now how do we know for sure that these intersections right here are 1 and negative 1? We can solve for that just to make sure that we're not making any assumptions here. So to solve that, all we just do is set these two functions equal to each other and solve. Okay, let's do that real quick because we don't have much time. So 6 over 1 plus x squared equals 3. Let's solve this. Cross multiply. You have 6 equals 3 plus 3x squared. Alrighty, subtract 3 from both sides. You have 3x squared equals 3. Divide by 3, you have x squared equals 1. When you take the square root, you have x equals plus or minus 1. So you can see that our assumption that this is negative 1 and 1 are in fact accurate. Okay, because sometimes it might not be exactly what you think, so we just need to make sure. All right, we have everything we need. Let's go ahead and put it into the formula. So our area is going to be the integral from negative 1 to 1 of f top, which is 6 over 1 plus x squared, minus f bottom, which is 3, with respect to x dx. Okay, now we're going to do term by term integration. Okay, we'll integrate this part first, and then we'll integrate this part next. So for the first one, we can factor out the 6. So we have 6 times the integral from -1 to 1 of 1 over 1 plus x squared dx minus the integral from -1 to 1 of 3 dx. Okay, so the method of integration for these two functions are different. So what's the integral of 1 over x squared? The integral of 1 over x squared is your arctan, so 6 times the arctan of x. All right, this evaluated from -1 to 1 minus the antiderivative of 3 is 3x, and this is evaluated from -1 to 1 using FTC part 1. Okay, so we're going to evaluate the integrand at the upper minus the integrand at the lower. So we're going to have 6 times inverse tan of 1 minus inverse tan of -1 minus 3 times 1 minus 3 times -1. Okay, so there's a small mistake I made in this problem right now in this step. And it's a common mistake that many students make. So do you see what the mistake is? Well, you notice that there's a minus here, and I just dropped down the minus, and I'm subtracting these two. That's incorrect. You have to put a parenthesis around here because this minus gets distributed to these two terms. Alrighty? Okay, so what is the inverse tan of 1 and the inverse tan of -1? We can use our unit circle for this. So let's do some work on the side. We want to find the inverse tan, the arctan of 1 and arctan of -1. Okay? All right, so let's just use the first quadrant to help us out here since it's positive. So we have our unit circle. Okay, so in the unit circle, we know what the axis angles, what the coordinates are, right? So just by inspecting the coordinates, we can easily figure out what the correct answer is. So we have the axis point, and then we have 3 points in between. 1, 2, 3. So since inverse tan of x, tan, remember what tan is, right? Tan is y over x. So we're basically looking for, change the color, inverse tan of y over x. Alrighty. So we're looking for the inverse tan of y over x, but if you notice, y over x is equal to 1. So we're basically looking for the point where y and x are identical. If they're the same, guess what? The quotient would be 1. Okay? So in the unit circle, this point right here is 1, 0. And then we have root 3 over 2, 1/2. And then this one is root 2 over 2, root 2 over 2. And then this one right here is 1/2, root 3 over 2. And then we have complete reversal right here, 0, 1. All right, so which one has x and y the same? You can clearly see that it's the midpoint right here. Bam. 45 degrees or pi over 4. That's the scenario where x and y have the same values, the same coordinate values. Okay, so that's pretty convenient for us. We know exactly what x and y are, and we know what theta is. So from this setup right here, the arctan of 1 is the same thing. We're looking for the arctan of root 2 over 2, comma, root 2 over 2. So which theta value will have x and y as root 2 over 2 and x as root 2 over 2? On the unit circle, it's pi over 4. So our answer for arctan of 1 is pi over 4. Okay, if you have the unit circle memorized, you can do this in a breeze. All right, so what is the arctan of -1? So we just have to remember that tan is an odd function. So this minus arctan of -1 is the same thing as negative arctan of 1, of positive 1. So we know that arctan of positive 1 is pi over 4, so we just put a negative over here. Negative pi over 4 is the arctan of -1. Okay, so let's put it in. So arctan of 1 is pi over 4 minus negative pi over 4 minus, here we have 3 times 1 is just 3 plus 3. So let's simplify further. We have 6 pi over 4 plus pi over 4 is going to be pi over 2. Okay. And minus 3 plus 3, which is 6. So we have 6 pi over 2 minus 6. 6 pi over 2 is 3 pi. 3 pi minus 6 is your final answer for question number 4A. All right, so how was this problem graded on the AP exam? Well, this was a 3-pointer. You have 1 point for setting up the integral correctly. You have another point for accurately finding the antiderivative. And then you have another point for getting the correct final answer. All right, for a total of 3 points. All right, let's take a look at 4B. 4B, you're being assessed on how to find the find the volume after revolving a region about an axis, about a line. Okay, so question 4B reads, write but do not evaluate an integral expression for the volume of the solid generated when R is rotated about the horizontal line y equals 7. Okay, all right, so before we get started with this problem right here, let's go over what the formula is. Alrighty, so we're looking for a formula for solids of revolution. Okay, so because we're rotating this region about the horizontal line y equals 7. All right, so where is that line? So this is 6. The horizontal line y equals 7 that we are rotating about is this horizontal line right here. Bam. Okay, so what's the formula for finding the volume of solids of revolution? Now you want to pay close attention to the direction of your rotation. Okay, remember when we're talking about finding the area, we said look at what direction are you pointing to when you slice the region. The same applies here. When you slice the region that we're rotating, what direction are we pointing to? Okay, so let's look at this. So if I slice this region, I'm rotating around this line right here, right? Okay, so if I slice this either up or down, if I slice it, what axis am I pointing to? I'm pointing in the direction of the x-axis. All right, so what does that mean? It means that the configuration of our formula for the solids of revolution is going to be in terms of x. Had if we were rotating around a vertical line, it would be in terms of y, because our slices will have a horizontal configuration. All right, so that is very, very important. So let's go ahead and write down the formula for a rotation in the direction of the x-axis, or a vertically oriented orientation. So we're going to write down the formula. Since the axis is above the region, that kind of changes things a little bit too. Above the region, we're going to have the formula v equals pi times the integral from, we're going to x left to x right, okay? So from x left to x right, everything is going to be in terms of x, of outer radius square I'm going to put r outer square minus r inner square dx, because we're rotating in the direction of the x-axis, okay? All right. Okay, so let's simplify a little bit further. You want to break this formula further, we're going to have pi. Now, don't forget your pi. That's a constant that students always forget, so don't forget that, all right? Remember p rho re, right? Okay, so this is the same thing as the integral from x left to x right, or a to b. The outer, now, since this is your axis right here, this is your axis, the outer function is the function that's further away from the axis. Okay, so consider this region. You have this line here, and you have this other line here. Now, which one is closer to the axis of rotation? This is closer, right? So this one is closer, and this is farther. So what does that mean? When you're rotating, you rotate your region. Let me show you what the region looks like. When you rotate your region around, that looks horrific, but just bear with me. When you rotate, and you have your nice little curve, right? Looks like a tire. The area that's farther out is going to be the outer radius. Okay, it's going to be the outer radius, and then the function, I meant to say, the function that's further out is going to be your outer radius, and then the function that's inner, that's closer, the closer function will form your inner radius right there. Okay, so that's basically the main idea. So let's go ahead and specify what our outer function is. Since this is further out, this is going to be f outer, and then since this one is closer in, this would be our f inner, okay, relative to your axis of rotation. All right, so our outer is going to be the radius of separation from the outer function and your axis. Okay, so this one, let's call this A. Axis is A. So it's going to be our outer is going to be, we're going to have the axis minus f outer. That's the formula. This entire thing square. This represents your outer radius, okay? Minus your axis minus f inner. Now, had it been that the axis of rotation square were beneath the region, these will reverse order. It will be f outer minus f inner minus a. So that's how that's going to be. All right, so we have our formula set up. Let's go ahead and set up. All we're doing here is setting up the integral. Okay, in this problem, we are not evaluating, we're just setting it up. All right, so x left is the left side of the region. We already solved that before. It's -1. X right is +1. Your axis of rotation, A, is 7. Your outer function, the one that's further away from the curve, is this horizontal function, y equals 7. And then your inner function is your rational function, which is 6/1 plus x squared. Okay, so we just put everything into the formula and we're good to go. All right, real quick correction here, sorry. Our f outer is not 7. Our f outer is 3, actually. Okay, sorry about that. All right, so let's go ahead and finish this off. Our volume is going to be pi times the integral from x left, -1 to x right 1 of 7a minus f outer, which is 3, quantity square, minus a again, the axis 7 minus f inner, which is the rational function, 6/1 plus x squared, square dx. Okay, so that's basically what the expression is. Let's put our bracket here. Okay, now this problem is a 3-pointer. That's how it was scored on the AP exam. You get 2 points for getting the integrand correct. All right, so this portion right here, It's really hard to set up. It takes a lot of work, so you get nicely rewarded with 2 points. And then you get another point for the limits and the constant pi right here. You get another point for that, which is very important. And then for this problem, you get a total of 3 points. All right, let's look at part C. Part C reads, let h be the vertical distance between x of f of x, basically a point on this function. This function right here is f of x, okay? So let h be the vertical distance between the point on this function and the horizontal line y equals 3. Okay, this line right here. Find the rate of change of h of x with respect to x at x equals 2. So we're looking for the derivative at a point or a slope of a tangent line. So what on earth is this h of x function? It's a vertical distance. So let's give ourselves a visual as to what it is first. And then we are going to go ahead and set up an expression for that. Okay, let's start it out. So h of x is, so let's see, we have a point. Just pick a point in f of x. And then you're looking for that distance, all right? Any point on f of x. So let's just call, let's just be our point that we're selecting, okay? So h of x basically represents the vertical distance. So how do you express this vertical distance right here? Since it's a vertical slice, our h of x is simply going to be f top minus f bottom. Okay, so hold on, let's freeze for a second. We're looking at x equals 2. Oh dear, we gotta be careful with that. So we're looking at x equals 2. So at x equals 2, we have a reversal happening. So let's put the line in the right spot. All right, so at x equals 2, it's going to be right here. Bam. Okay, so we're looking for that vertical separation. All right, very important to make sure we are drawing it at the right spot. Well, why is that? Well, this function right here, this is h of x, right? H of x is basically f top minus f bottom. That's what the vertical distance is. F top minus f bottom. Okay? Now, at 2, the horizontal line is the f top. Okay? And this rational function is your f bottom. So h of x is going to be 3 minus f bottom, f of x. Okay? All right, so let's do it. First things first, we want to find the rate of change. What on earth is that? How do you find the rate of change? So let's call Navigator to help us out again. So let's put up our split. When you're looking for the rate of change, you're looking for the slope of a tangent line or the derivative. So the rate of change at 2 is basically the derivative at 2. Okay? So what we're looking for, we want to find h prime of 2. That's exactly what we are looking for. Alrighty? So to find h prime of 2, we know that it's a 2-in-1 process. We want to find the derivative first, and then after finding the derivative, you want to evaluate that at 2. Super. So let's do it. So h of x is 3 minus f of x. Alrighty. So h of x is, so we know what f of x is. F of x is a rational 6 over 1 plus x squared. Okay? All right, so let's do the first part, part 1. We want to find the derivative h prime of x. Okay, so let's look at what we have here. How do we differentiate this? Well, term by term differentiation, okay? If you are differentiating So h prime of x. So you're going to differentiate 3. Now, if you're differentiating this quotient right here, this rational function, you are going to be using the quotient rule, okay? Do you remember what the quotient rule is? Hopefully you do. So oh snap, u over v, high over low, u over v squared is vu prime minus uv prime, vu prime minus uv prime over v squared. Low d high minus high d low over low low. Okay? Alright, so our u is 6 and our v is 1 plus x squared. Alright, so the derivative of 3 as a constant is 0 minus v 1 plus x squared. U prime, the derivative of 6 is 0 minus u 6. U prime, derivative of 1 plus x squared is 2x divided by low or low square, or v square, which is 1 plus x square quantity square. Okay, let's make it look pretty. H of x, nope, h prime of x is equal to this minus times that minus makes it a plus, is equal to 12x over quantity 1 plus x square square. Okay, so we're done with part 1. Part 2, we're done with the calculus part. Now is the algebra part. We're going to evaluate the derivative at the specified value, which is 2. So h prime of 2 is 12 times 2 over 1 plus 2 square quantity square. Okay, so let's PEMDAS this real quick. Order of operations, 24 over 4 plus 1 is 5 square. 24 over 25 is the answer to question number 4C. Okay, all right, so for this one is a 3-pointer also. First point is accurately determining what the function h of x is, f top minus f bottom at x equals 2. So you get 1 point for that. You get another point for differentiating correctly, finding what h prime is using the quotient rule over here. And then lastly, you get another point for evaluating the derivative at the specified x value. Alrighty, for a total of 3 points for question number 4C. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your studies of preparation for the upcoming AP exam, do give us a like. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel. We upload videos to our page on a regular basis. And if you have any questions or comments about what we covered in this presentation or any calculus related question, just post it in the comment section below and we'll be more than glad to assist you. Don't forget to visit our website at mathgotserved.com for tons of resources to help you prep for the AP Calc exam. Thanks again for watching and have a wonderful day. Goodbye.